limit shows the graph's behavior as it approaches a given value. If we are given a polynomial function, then the limit as it approaches to x equals c is f of c. This is a direct substitution method which is only applicable to functions with a determinate solution. However, if we always apply direct substitution, most of the time we would end up in an indeterminate form, like any values over 0 or answers with infinite. But this does not mean that there is no limit for this function. We could try using another method to solve for its limit. Let us take a look at this example. The limit of the square root of x minus 2 over x minus 4 as x approaches to 4. We can observe that the square root of x quantity squared is just equal to x, and the square root of 4 is just equal to 2. We will then simplify this equation into the square root of x minus 2 all over the square root of x quantity squared minus 2 quantity squared. We can observe that the denominator shows an example of a special product in the form x squared minus y squared, which is equal to x minus y quantity x plus y. And now we can express this into the form square root of x minus 2 all over the quantity of x square root of x minus 2 times the quantity of square root of x plus 2. By simplifying this, the square root of x minus 2 over square root of x minus 2 will be cancelled, as it will only result to 1. And then this will have the limit of the 1 over the remaining square root of x plus 2 as x approaches to 4. We can now try to directly substitute 4 into the equation. 1 over square root of 4 plus 2. Doing some algebra, we will have 1 over 2 plus 2, which is equal to 1/4. Therefore, the limit of the square root of x minus 2 over x minus 4 as x approaches to 4 is equal to 1/4. It is represented by this graph. Let us now proceed to infinite limits. Infinite limits also exist. They are sometimes one-sided and the limit does not exist. It is because its limit increases or sometimes decreases infinitely or without bounds. Let us take a look at this next example. This is the limit of square root of 3 plus x squared all over x as x approaches to 0 from the left. We cannot also apply the direct substitution here as it would result to an indeterminate form. Therefore, we must express this into another form. Let us first try to separate square root of 3 plus x squared and 1 over x. And then, this would result to a new form, the limit of the quantity of square root of 3 plus x squared as x approaches to 0 from the left, multiplied to the limit of 1 over x as x approaches to 0 from the left. Solving this, we would derive that the limit of the first function here is equal to square root of 3 or a constant number c. Then the limit of 1 over x as x approaches to 0 from the left is negative infinity. Multiplying a constant number to negative infinity would result to a negative infinity. Therefore, the limit is negative infinity. This is the precise definition of infinite limits. So these limits only exist for real numbers. So always remember to review and practice. Push yourself to your limits, and that's how you truly grow. Thank you for listening, and see you next time.